Okay, so we're going to have another example that can be solved either by using the relative velocity equation, or it can be done also by using the IC method. So in that case, we have a crankshaft AB that turns with a clockwise angular velocity of 10 radii per second. We need to determine the velocity of the piston at the instant shown. So now let's have an analysis of determining the solving procedure. First, we need to know how the thing is going to be done. So this link is going to rotate to the clockwise direction, and thus we are going to have a velocity that perpendicular to that link. Now that's the VP. By having the crankshaft, mainly the piston is going to be moved in upward direction, where it's going to be just vertical one, doesn't have a C direction. So this one can be found, and then we are going to sketch the line that's going to be perpendicular to this velocity, which is going to be mainly horizontal line. Another line is going to be perpendicular to this velocity VP, which is going to be extension of the link AB, and they're going to be intersect at that point, and that point is going to be the instantaneous center for the zero velocity. After we find that, we know that this angle is going to be similar to that angle, which makes it 45. And we got also this angle is 13.6. So we can find this angle directly. And the third angle is going to be 180 plus the 45 minus the this angle here. It's 76, I think. Okay, and we can find this one. Using the sine rule, I can find the length of this link and the length of that link. Once again, the velocity C is perpendicular to this link. So if I get to find, if I know this velocity, which is perpendicular to that link as well, I can find the omega of that link. The whole triangle can be considered as one solid part. So the omega is going to be the omega on any of those links. And thus, if I get to know what the omega of that link, it's going to be that direction, which is going to be the same as that one. I can calculate the velocity by multiplying the omega multiplied by the length of the link from the IC to C. So let's see how the thing is going to be done. First, we're going to start with the easy step by calculating the velocity B, which is going to be equal to the omega AB multiplied by the RAB. And that will give me that the VB is going to be equal to 10 radian per second multiplied by 0.25 meters, and this will give me 2.5 meters per second. That was the easy part. Now the second part is we're going to simply have the direction of velocity VB and the VC are known. So the VC is going to be vertical and the VB is perpendicular to the link AB. So I can then find the location of the IC for connecting the road BC, and it's going to be at the intersection of the lines extended from these points, perpendicular to the VP and the VC. So this will be the first one, and that will be the velocity VC direction, and this will be perpendicular to it. And we're going to have the IC point. Now we have all the angles. We have 45, 76, and 58. I can use now the sine rule to obtain the length of the RBIC and the RCIC, which can be obtained by using the sine rule. So for the RCIC, I can simply have that the 0.75, which is the length, BC length, divided by the sine of 45, is going to be the same ratio of the RCIC, okay, that link here, okay, divided by the sine of that angle, which is 58.6. By solving this one, I will get that the RCIC, that length is going to be equal to 0.9 or 6 meters. If I get to repeat the same process for the link B to IC, I will find that the RBIC is going to be 1 meter and 3 millimeters, 3 centimeters. So now I have this length. I'm going to start to solve for the omega BIC and the VC. Now remember that the omega here is going to be the same the omega here and the same omega here, because now we can consider that as a solid piece, solid work. So now let's see how we can find the omega BIC. Now this velocity here is perpendicular to that link here. So this velocity is going to be equal to the omega of that link multiplied by its length. Or the omega BIC is going to be equal to the velocity divided by the R BIC. Now we know both values, so we can find that the omega is going to be equal to 2.425 radian per second. That will be the first part. Now I know what the omega of that link, and I know its length, which is 0.906. So I can find the velocity of the point C, which is going to be equal to the omega BIC multiplied by the RCIC, and this will give me that the answer to be 2.2 meter per second. So it's not actually complicated, but it's very easy to be solved. Okay, so that's it for the last question we have for the relative velocity equation and the IC method to solve for the velocities. And the week 3 is going to be about the relative acceleration equation. Thank you very much for your listening, and see you soon.